We have sound test number 1. The question at hand is whether lines A and B are parallel. There are really three options. It says here they are definitely parallel, definitely not parallel, or you can't tell. And notice this statement, we want a logical argument. We're trying to prove whether they're parallel or not. And that is going to take a little logic. Up here there is a note. In our calculations you'll notice that there's some decimals. For this question there's a rounding tolerance which is given of 0.01. So if we have 101.09 and 101.08, those are actually close enough to be considered equal. So let's get started. We don't know that these lines are parallel. So in order to prove that they're parallel, we're going to use those parallel line relationships that we learned earlier. We can make a little list of them. We have our alternate interior, alternate exterior, same side interior, and same side exterior, and of course corresponding. We can use any one of these and we look at the diagram and see which one can we get. Now the concept here is we can turn the statement around, because we know if lines are parallel then alternate interior angles have to be congruent. If lines are parallel then alternate exterior have to be congruent. All right, and these are supplementary and corresponding are congruent. So we turn this around and say, well, if alternate interior angles turn out to be congruent, then that implies that the lines must be parallel. This is the logical argument that we can construct. So what we need is to find a pair. So if, for example, we found that angle, that would be the alternate interior angle to 101.09. Or we could find this angle, excuse me, which would be the same side interior to 63.1. So we need to get some kind of angle somewhere. So this becomes like a complex figure. We see this big triangle here. We have these two angles. We should be able to calculate that third angle A. Once we get that third angle A, well, I'm seeing, and let me quickly do some erasing. And now we can get kind of a plan of attack. We can get angle A from this big triangle here. And what I'm also seeing I'll use a different color, here's another triangle right here, where once we get A, we'll know that one. We know the 63.1, and we should be able to get this angle B. Now this angle B is the same side interior to 101.09, which means that would give us enough to prove whether the lines are parallel or not. So let's look at angle A. We know that this is our sum of a triangle equals 180. So we have 82.03 plus 59.97 plus A has to equal 180. And we can add these two together, and that actually equals 142. And solving for A, we get A is 38. Number 1. So once we have that, now let's shift to B. And we still have sum of the triangles equals 180. Now we have 38 plus 63.10 plus B equals 180. And we can combine. This turns out to be 101.1. And if we solve, we get B is equal to 78.9. All right, now what we can do is, well, B is 78.9. Are these supplementary? Well, the question is 101.09 plus 78.9 equals what? Well, we add those together and we end up getting 180.8 is equal to 101.09 plus B. Well, that's the number we needed. Are the lines parallel? The conclusion is definitely not parallel. Now, I've circled the answer here. You need to actually provide a statement with reasoning. So we could say line A is not parallel to line B because same side interior angles are not supplementary. This is your answer. Right? Notice that if this was 180.01, it would still be within our tolerance, and we could say they were parallel. But this is way off from that. So clearly, they are not parallel.